Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to look at another electronic quiz. We're going to calculate the input impedance of this amplifier which using some resistors, and this is an ideal op amp. Okay, but before we get started, if you're new here, please give me a thumbs up, hit that subscribe button and also the notification bell so whenever I upload a new video you'll be aware of it. Let's jump into it. This is our circuit, and here are all the possible options for this question. So this is an ideal op amp, and in an ideal op amp we have two interesting assumptions. First, the current through the input of op amp is 0. Okay, and these two nodes have the same voltage. So for example, if I let me change the color. If I call this node Vy, this node again is Vy. And in order to calculate input Rin for this amplifier, we had to place a voltage test such as this one. I'm going to call this Vx, and the current through it is Ix. So now our problem is that Ri equals to Vx divided by Ix. You just have to find the ratio between Vx and Ix in this problem. Okay? But first, you have two other unknown variables such as Vy and Vo. If we come up with some equation relating to these unknown variables related to Vx or Ix, the problem solved. Now, if you look at this node in here, the positive input of op amp Vy, if you look at it closely, this resistor and this resistor are in series because there is no current through op amp. So these two are in series, and you can use your voltage divider for series resistors in here to calculate Vy in terms of Vo. So Vy here equals to this resistor R divided by this one plus 19R times this voltage, which is Vo. So this is 20R and this is R. So Vy equals to Vo divided by 20. This is our final result. Vo divided by 20. This is our first equation. Now, from here, instead of Vy, I can write Vo divided by 20. Now, one of the variables eliminated. Now, I just had to find the relation between Vx, Ix, and Vo, and somehow eliminate Vo. Okay. Here, you can use KCL in this node. For this node, KCL at V minus. V minus, I mean the minus input of the op amp. So this current Vo divided by 20 minus Vo divided by 9R in here, and the other is this current Ix. So minus Ix equals to 0. Now, in this way, we can come up with a relation between Vo and Ix. It's completely crystal clear in here. So here I get the 20 as the common denominator. 1 minus 20, which is minus 19 VO divided by 9R minus IX equals to 0. So it's better to calculate VO from this equation. IX move to the right hand side, and this 9R is multiplied by IX somehow divided by this 19 in here is a multiplication, so it's going to be on the denominator, and 20 just going to the numerator, but the sign is minus. Okay, so this is the last relation between VO and IX. 9 times 20 minus 180 R divided by 19 times IX. This is the relationship. Okay, now the other thing is that IX is the current through this resistor R, which is between Vx and this node VO divided by 20. Okay, so now I can use this current Ix equals to Vx minus VO divided by 20 divided by R. Okay, so somehow R times Ix equals to Vx minus VO divided by 20. Now VO divided by 20, instead of VO, I'm going to use this equation in here. I'm going to substitute this because I want a relationship between Vx and Ix. You just have to find one equation that just have Vx and Ix to calculate Ri. So minus 180 times R divided by 19 Ix. This is instead of this VO divided by this 20. Okay, 20 in the denominator. So these two are minus becoming plus sign. 180 divided by 20, which is 9 in here. So now we can have our equation. Just let me check if I'm not doing anything wrong till here. This is yes, this is R times Ix. Okay, now here what we have R times Ix equals to Vx plus this value 9 divided by 19 R Ix. So if you calculate it, simplified it, Vx divided by Ix equals to this R minus this term in here, R minus 9 divided by 19 R. So you can factorize R, and between these two, 19 are a common denominator. 19 minus 9, which is 10. 10 divided by 19 R. So this is our R input for this problem. So option B is the right answer. Okay, just to recap this video, in order to calculate Ri, I put some V test and I test, which I called it Vx and Ix in the input from the node that we're going to see through this circuit, and the ratio between Vx and Ix defined as Ri. And in this problem, you just have to your KCL, you just have to use your KCL&KVL, and you just have to know that this is the things that you had to already know this. Okay, for using an op amp, this is an ideal op amp. Be careful, this is an ideal op amp. In a real op amp, we don't have these assumptions, but in most cases, it's approximately true. Okay, the input current through the op amp is 0, and these two V minus and V plus, these two nodes are the op amp. The input voltage of these two nodes are almost the same. Okay, so bearing that in your mind and use this algebra, you can come up with the solution. I hope you like this video. If that's the case, please give me a thumbs up and share this video with your friend. Thanks for watching.